Hello class, this is going to be a recording of 8.6 in chapter 8, so you'll see one more recording other than this one for 8.7 and then chapter 9. This basically is about finding the vertex of a vertical parabola, graphing quadratic functions, which is something that we have already kind of talked about. So it's more about the parabolas and their applications. How can we use those quadratic functions to solve problems that involve maximum or minimum values, and how can we graph them if they have horizontal axes. So the first objective is to find the vertex of a vertical parabola. If I have a vertical parabola, typically I'm looking at this equation that has the form of a quadratic equation, ax squared plus bx plus c. We need to locate the vertex to sketch an accurate graph in such a case. So there are two ways to do this. Go ahead and try completing the square method so that you can have x plus h plus any number squared, and then they use the formula that's derived from that squared method. So let's go ahead and see an example. So if I have this graph, if I want to factor it, I need to try to do the either factoring, or I could do the complete the square. So if I do the complete the square method in this case, I am going to have the following: x squared plus 4x. You remember you have to find half of b. Right there, half of b squared, or b over 2 squared. So this is going to be equal to 2 squared, which is 4. So that will be plus 4. And you're going to make sure that you add 4 and then subtract 4. And then go ahead and combine these right here so that you will have a complete square over here, which is x plus 2 squared minus 13. So now this looks familiar. If this looks like the previous section, which was, I believe, 8.5, where you had x plus h squared minus k or plus k. So in this case, the vertex would be -2 and then -13. So here's another example. Go ahead and find the complete square for this one. First of all, factor out the 2, because you can do that. And then because you do, if you remember, with the complete the square method, you want to have 1 as a coefficient for the x squared. So you want to factor out the 2 from only the variables, only the ones that have the variable x. That will be 2 into x squared minus 2x plus 1. And then you're going to complete the square for this one right here, which will be 2 into x squared minus 2x plus 1 minus 1, because this is equal to 1. So that would be 2 into x minus 1 squared, right? And so remember to keep this. This is still inside the parentheses. This has to be multiplied by this coefficient out here. This is why you have 2 into minus 1 plus 1. So it's going to be a vertex of -1 and -1. So a graph of a quadratic function, I believe Christian was saying this in class earlier today, that it's easier to find the vertex by minus b over 2a and f of minus b over 2a. So the x value would be minus b over 2a, the y value would be, of course, the y value at that x. So this is how you would find it. The axis of symmetry is minus b over 2a, so this is the vertex formula. So use the vertex formula to find the vertex of the graph. All you have to do is just apply it. Find your a, find your b, and find your c, and then you just plug them into the equation. You're going to find your x value, and it's 3 over 4. Then you're going to plug that 3 over 4 into this whole quadratic function, and you're going to come up with a value for it, which is going to be equal to 1 over 8. In this case, you have fractions. So the vertex will be 3 over 4, 1 over 8. Make sure that you do this before you look at the answer. How do we graph a quadratic function? You're going to determine, first of all, whether it opens up or down. If a is positive, remember, the parabola opens up. If a is negative, then it opens down. Then you're going to find the vertex. You could use the vertex formula or completing the square. So this is these are two methods. It's a lot easier to use the vertex formula for most of the time. You're going to find any intercept. So to find the x-intercept, and you're going to solve for f of x equal to 0, where it intercepts the x-axis. It's going to be it's going to have a coordinate that is y equal to 0, and then you're going to find where it intercepts the x-axis. Sorry, the x-axis, where it's going to be f of 0. So the y-intercept and the x-intercept, and then you're going to plot the points. Just connect the dots on the graph. So graph this quadratic function, give the vertex, axis, domain, and range. First of all, from the equation you can see that a equals 1, so it's positive, so the graph is going to open up. You're going to find the vertex, so use the quadratic formula. The vertex is going to be 3, -4, so you already know where the lowest point is, and then you're going to be able to look at the x-intercept where f of x is equal to 0, so y is equal to 0. You solve for that, so x could be equal to 5 or 1. We'll see what it is. And then you're going to find the y-intercept, 0 and 5. This is where x is equal to 0. Always the y-intercept where it intercepts the y-axis. This is where x is equal to 0. The x-intercept is where y equals to 0, and this is, in this case, it's 2 points. The vertex is 3 minus 4, so I'll go ahead and plot that. 3 minus 4. I have x equal 1, 0. I have x equal 5, 0. And then 3 minus 4. And then I also have this other point, 0, 5. Therefore, I will connect the dots. This is the axis of by symmetry. 6, 5 is also a point on the graph. Because it's a symmetry, this is the graph. So you really don't have to use the table, the data table, in order to solve these. You could just find the vertex. Let's go back one slide. You find the vertex, you find the direction of the graph. Is it opening up or down? You find the vertex, then you find the y-intercepts and the x-intercepts, and that's it. Okay, here's another. The axis of symmetry in this case is x equal to 3. The domain is all the way from -infinity to +infinity. And then the range is going to be from -4 all the way to +infinity, because it can't be any values below here. The third objective is to use the discriminant to find the number of x-intercept of a parabola with a vertical axis. How many times does it intercept the x-axis? The discriminant is used basically to determine only how many x-intercepts a graph could have. The three possibilities are shown on this slide. So if the discriminant is positive, the parabola will have 2 x-intercepts. If it is 0, there's only going to be 1 intercept, and that will be the vertex of the parabola. If it's going to be negative, then the graph will have no x-intercepts. So this helps you determine. So if you can see, this is the discriminant rule. Please remember this rule, b squared minus 4ac. If it's positive, you can see it has 2. 1, 2. 1, 2. If it's 0, it only has 1, which is the vertex. It's kind of like the parabola lies on the x-axis. If it's negative, then it doesn't really touch the x-axis at all. So here's a discriminant for this case, A, B, C. Identify it. What is it going to be? Positive. So this means that there are going to be 2 x-intercepts. I'm going to, you can find them, or if you're not asked to find them, you don't have to. In this case, the discriminant is going to be negative, so therefore it has no x-intercepts. In this case, it's going to be 0, so therefore it's going to only be the vertex, and we will find what the vertex is. As simple as that, you guys. So it's it's really not complicated. This chapter is more like a set of rules that I have to remember and I have to apply. The fourth objective is really to use the quadratic functions to solve problems that involve maximum or minimum values. So what does that mean? If I have an applied problem such as this one, if I have a farmer that has 100 feet of fencing to enclose a rectangular area, we're going to find the maximum area he can enclose and the dimensions of the field when the area is maximized. So let x equal the width of the field. This is what we're trying to find, the maximum area. We need to find the area. So remember, the area basically is going to be so if x is the width of the field, you're going to have the width of the field plus because it's a rectangular area, plus the width of the field plus the length. That's going to be equal to 100. So therefore 2x plus the length is equal to 100. So therefore the length has to be equal to 100 minus 2x. So this is where it came from. See, there's width, and then length. So it's 2x is equal to, plus the length is equal to 100, so the length is going to be 100 minus 2x. So the area is always the length times the width, so it's going to be x times that, so therefore you're going to determine the vertex by the vertex rule. This is going to be the vertex, and then you're going to see how does the parabola open, down or up. It opens down in this case. Shows the maximum area will be 1,250 feet squared. So these are just typical application problems so that you could actually go through yourself as well if you want to know more about applications. Graphing parabolas with horizontal axes is also another kind of a way to look at parabolas, where instead of having the x in here, you have the y. So it's basically the vertex is hk instead of kh, if you remember, and then the axis of symmetry is not going to be x equal to something k, it's going to be in this case y equal to k. So, and then it's also, if the graph opens to the right, then a is positive. If the graph opens to the left, then a is negative. So this is another way to actually look at parabolas. So here's an example where I would have x is equal instead of y equals, right? What is the vertex? It's going to be hk, right? So -4, -1. Then it opens to the right because a is positive. This a right here is positive. And then the axis is going to be -1. You can also plot those points and see what it looks like. As you can see, it's a horizontal parabola. It's not a vertical parabola. So you treat it the same way like you treat the vertical one. And here's another example that I want you guys to do on your own as well. In this case, you have to complete the square method in order to solve for this, and then you're going to find your vertex. In this case, it's 6, 1. Axis of symmetry is always this number right here, which is 1. It's going to open to the left since a is negative. So these are just the set rules for this. So here's a summary table, a very important table. It's very helpful. Please keep this in mind, and always use these predictions here, like a is greater if it's greater than 0 or less than 0. Always use these to determine if your graph is correct or not. This is it for this lecture, and I will record one more lecture for you guys, and I look forward to hearing your feedback. Thank you very much for listening.